Alright, this is a video to help explain what's going on with, this is page 45, applying the concepts, numbers, well, it's actually not one of the homework problems, it's just a problem that somebody asked about. And basically you're constructing a frequency distribution for the data. So I'm looking at part 4, so if you're on that page, if you look at part 4 of that particular assignment, you'll see where I am. Alright, so part 4 addresses the question of constructive frequency history, frequency distribution, excuse me. So we're looking to make a frequency distribution. Alright, so the data that I was given, I sorted through, and what I did was, I put my list down in order from smallest to largest or largest to smallest. So that helped me see my largest number and my smallest number. It took me a moment, but that's part of the process. You gotta remember, in statistics, we're organizing our data. Now, um, here real shortly we'll learn how to do all this stuff with your calculator, and so basically we'll have technology tools to help us organize our data and so forth. But if we're going to go and do it by paper and pencil, this is one of the processes that we go through. Well, what we know is that our range is 27 when we do that. So we take our largest number and our smallest and subtract them. If you want to reference in your book, if you look at page 41, there's a great example, example 2-2. So on page 41, you have example 2-2, which is a great example. It kind of walks you through the process of kind of what I'm going to explain or talk about. Um, on that page, basically what we know is that we know that we can choose the number of classes. Okay, there's no way bounding us to the number of classes that we want for the data. Um, the more classes we have, the more spread the data will be. I'm sorry, excuse me. The more classes that we have, the more, I guess, precise our data will look, and that we'll be able to kind of see smaller quantities because our class width will be smaller. However, at the same time, it does kind of spread things out and make things look more spread. Even though it just all depends on the class. So that's kind of what one of the questions is asking. One thing to remember is that we want to try to make our number of classes odd, and the reason is because then that allows us to have a nice even midpoint. It gives us an easy way to get a midpoint. So I'm going to start off here, and I'm just going to kind of show two different ways that I would think about this problem. Since I find out that my range is 27, what I'm going to do is I'm going to take a look at what would happen if I had 27 as my range, and I decided that I was going to go with 7 classes. Alright, so in that case there, that means that every one of my classes, and I got my calculator, sorry, that means every one of my classes is going to be approximately 3.85, except I have to round that up. So I round that up to 4. Alright, so now once I have that identified, I have to come up with my starting point for my class limits. So let me write this in here, class limit, and my pen's not working very well. So I need to choose my own starting point. I could start with 42, but just from a little bit of experience and a little bit of trial and error, really trial and error probably more so than anything, I decided to start at 40. So that means my first class will go from 40 to 44. Now I'm going to go ahead and jump to my class boundary real quickly so you can help people understand what's going to happen next with this. Okay, so my class boundary would be 39.5 to 44.5. Alright, that means that my next class boundary would start at 44.5. Alright, well if that starts at 44.5, that means my next class limit is going to start at 45. Now, the textbook just really explains very briefly that, because of your class boundary, if this is 44, then your next class limit would be 45. And every time you would just keep adding 1. So then you go from 50 to 54. And then from 55 to 59. And from 60 to 64. And that's 1, 2, 3, 4, 5. And I'm going to 7, so I go 65 to 69. And from 70 to 74. And I'm not really worried about my class boundaries. I think that we can finish those up from there. So I'm just going to put dot, dot, dot. Because, I think once you know your class limits, it's pretty straightforward to find your class boundaries. Now, here's my concern. I go to 69. That's my largest data value. But my data goes all the way to 74 because of the fact that I said I wanted 7 classes. So, the deal is that because of the fact that I kind of had to fudge, I had to round up first of all, because, my range was 27, I wanted 7 classes, I had to round up, that kind of messed with me a little bit. So, at this point, we are just learning the process. We're learning if you can create one that helps you understand what you're interpreting. And so that's really what we're doing here is we're trying to create a frequency distribution so that we can kind of understand better when we read them what we're seeing. Now, if I was to go back and make some changes, so let's say that I wanted to do this a little bit differently. One thing that you could do is that we could make adjustments. So I could, instead of starting at 40, I could maybe start at 38. And so if I started at 38, then that would finish me up at 72. So when I got down to the last one, I would end at 72. So it'd be 38 to would be a 42, and it would keep on going until I got down to, what would that be, 68 to 72. So, then each one of my classes that were drawn, then they would have data in them, so it's a tricky line, it is kind of confusing as to how you set it up, how you design it. Now, notice here, I chose 7. Well, what happens if I chose 9? So what happens if I decided, okay, well, I'm going to go ahead and I'm going to go with not 7 classes, I'm going to go with 9 classes. Alright, so now I have 27 divided by 9. Well, I get a nice, neat number. I get a width of 3. So when I set that up, let's just say I start at 40 again. Because I don't know any better, so I start at 40. And I go 40 to 43. And I go 44 to, and I'm going to push pause for 1 second while I do this. Alright, I'm back. I just didn't want you to sit there and have to watch me write all 9 of those classes, but here I am, 1, 2, 3, 4, 5, and 4 gives me 9. The problem is here is that worked out nice and neat, but look what happened. I now have a class that isn't going to have a single number in it because my largest value is 69. And so one of my classes, actually a couple of my classes, go from 70 to 73, 74 to 77. So, you're going to have stuff like that happen. It's just the design. When we build things and set them up. So, you can play all day until you get the right class width that gives you the image that you want. But the point is that once you put this data in there and you look at the frequencies, it tells you where the data is located. And that's what matters. When I made my little design, I made myself a stem and leaf plot, which you'll learn about later. And in a stem and leaf plot, I saw kind of where my data is grouped. My data is grouped basically right here. Majority of my data comes from 50 to 59. So, no matter how I set this up, I'm going to see that the majority of my data comes from that area right there, that 50 to 59. And so that's kind of what's going on here. That's a basic rundown of how to create yourself a frequency distribution. Right? It's not a rocket science in the sense that there's an exact procedure. It's something that's very arbitrary. All right? Let me know if you have more questions.